Hello, I'm Thomas Hoppus, and my topic was machining. The article title was Optimization of Cutting Parameters with a Sustainable Consideration of Electrical Energy and Embodied Energy of Materials. It was in the International Journal of Advanced Manufacturing Technology in 2018. The main topic was energy consumption in machining, and the main question was how can energy be saved during the machining process? So it used the multi-objective optimization to look into all different factors that go into machining or milling a part. It looked into the cost and length of life, energy use. The materials used were tungsten carbide for the cutting tool and S45C carbon steel for the working piece. The first question was what cutting parameters influence tool life the most? This is part of the indirect energy consumption of the machining process. It would be considered the tool life. So on the far right side is the tool life and how long it's lasting in minutes. And there's all the parameters of like cutting depth, cutting width, speed the tool is actually moving across, and it also gives the energies that is used. Um, so the material for a milling tool must be durable, machinable, with good tolerances, high hardness, roughness, and heat resistant to be able to have a good tool life and not use excess energy. The second main question was how does the rate of material removal affect energy consumption? So both direct and indirect energy consumption make up for the total amount of energy consumed. Indirect energy consumption could consist of the tool being machined, and anything pre or post process in the machining process, not when the actual machine is running and the electrical energy used. So you can see the total at first goes down as the material removal rate goes up, but then as the tool energy goes up and the tool changing energy goes up, the the total energy consumed will increase. So this showed that the cutting tool material must work well with the material that is being worked. It must be much harder and have good wear resistance so it doesn't wear down fast and you have to keep changing tools. So for the first atrophy diagram that I did, I used the working material. Um, you should have a lower hardness so the tool can cut through it. So the ones I showed, of course you can cut through foams and most metals, but when you get into ceramics that are really hard, that would be harder to cut, and you need a much harder material, like even a diamond type bit, to be able to cut through it and drill. I also, on the x-axis, included price because you don't want too costly of a material to machine either. For the second Ashby diagram, I used a more advanced function, the level 3, on the Granta software, and this looked into the actual tooling material or tool steel as it's called. So we looked in the hardness of it, and we also looked into the wear resistance, both two very important factors in how fast that tool will degrade and how much energy will have to be used. Um, so as you can see, like as you get farther to the top um, right of the diagram, those are going to be the better tools. But as you'll see on this next diagram that I have, that it's actually they get much more expensive as they get better. So there's a good balance there that you have to look at. The milling tool should have good wear resistance and be very hard, and it also should be able to be machined very easily and not have to use a lot of energy to machine it. Um, Otherwise, it's going to be very costly and not very energy efficient and add to that total energy in the machining process. So in summary, many factors go into the energy use and consumption in the milling process. Both direct and indirect make up the total energy use. However, cutting velocity, the speed at which the tool is moving across the surface, shows to be the most dominant, and a slower cutting velocity should be chosen because it showed that it had the most effect, and a slower cutting velocity led to less energy consumption. The research should have used more materials, in my opinion. for the bits and for the materials of the working piece, only one of each were used, and I would like to see if changing material would have any effect on it or if it would stay the same.